Okay, we'll start now. I don't know. Teams is hanging in between. I don't know why. Okay, so in the last class, what I covered was the metrics of biometrics. I told you that within there are intra and inter-class variations. When I say intra-class, within the same person. Today you give your biometric. You give your biometric after 10 days, after 1 year. There are 3 samples of your biometric. All that there will be changes and all that is intra-class variations. Then inter-class means between you and somebody else. You are giving your biometric, somebody else is giving the biometric. That is the inter-class variation. Then I also told you about the false acceptance rate and the false reject rate. False acceptance rate means somebody who is not supposed to be in the system is accepted, and false reject rate means somebody who's inside the system is rejected. So these are the things that I covered in the last class. Then I also told you about various there are some statistical parameters. That is very small and it is below a threshold and it is an authentic score. So every authentic score there will be a threshold. I'll give you an example. Today I'm giving my biometric, my fingerprint. After 3 months I cut my hand. Then after when I cut the hand, obviously I cannot use my fingerprint. I have to wait till the biometric grows back and so on. After 6 months, I again put the biometric. There will be some small minute changes in the biometric, but that will be within the threshold because it is my own fingerprint, right? So that is the authentic score. An imposter score means anything that is above, it will be an imposter or a false person. Then I told you about various, the EER is where the FAR and the FRR, the false accept rate and the false reject rate, meet or diverge. That is the EER or equal error rate. This is a linear scale, this is a logarithmic scale. Then I also told you about the Dodington Zoo. Human beings, we can classify them into 4 kind of people based on the biometric. A sheep is somebody who is very cool. I mean, he cool in the sense that he doesn't have a problem. He or she doesn't have a problem. His biometric is pretty unique, very low intra-class and inter-class overlap is there. So there should be no problem. A goat, on the other hand, is a person who is prone to false reject. When I say false reject, means maybe through old age, many a time your fingerprint gets, somehow it gets wrinkled and so on. So these are the goats. Generally, they are old people whose biometric generally gets rejected on and off because of old age and so on. A lamb is somebody who is an easy prey. As you know, a lamb is somebody who can be easily preyed upon or hunted. So here the lambs are the people who have high, who can be easily spoofed by others. In other sense that their inter-class variations are low. So anybody can easily spoof them, cheat them because their biometric is easy prey for the others. And a wolf is somebody who's a cheater, who's an unethical person who always tries to modify his or her biometric to influence, to spoof and to cheat others. These are the 4 kind of people. Now, all this points out to the fact that, we have FAR and FRR that is very unacceptable. Now, I told you, if you ask me, an FAR, a false accept rate, should be 1 in a billion. Point not 1. 1 in billion. It cannot be 1 in 100. It cannot be 1 in 1000. Even 1 in 1000 is unacceptable. If your FAR is 0.01 or something, 1 in 1000 people is accepted falsely. It is unacceptable because that 1 in 1000 person who is being accepted falsely into the system may turn out to be a terrorist, a criminal. So it is absolutely unacceptable. We need to have the lowest possible FAR and we need to have the lowest possible FRR, false accept rate and false reject rate, which are extremely low, so that there is no problem. And most of the biometrics, they don't have this kind of capability, even though iris and retina have FAR and FRR, which is say 1 in 10,000, 1 in 100,000. The others are not so good. In some, you may have FAR of 2. That means 2 out of 100 people are falsely accepted. FAR of 5. 5 out of 100 people are wrongly rejected or falsely accepted. All this is absolutely unacceptable. You need to have the lowest possible FAR and the lowest possible FRR. And for that, we have what is known as multi-biometrics or multimodal biometrics, where we are combining more than one biometric. There are people who have high intra-class variations. The lamb, it's a big problem. There are people, there is noise always in the system. You put your fingerprint, there is some dirt, it doesn't accept. There are people who are spoofing you. There is a problem of distinctiveness. Suppose you have two identical twins. More or less everything is the same. Identical twins are having the same, almost 99.9999% DNA is the same. It's all problematic. So that is why we go for a combination of biometrics that is known as multimodal biometrics, so as to reduce that FAR and FRR. Now, how do you make multimodal biometrics? There are various ways. You can have multiple biometrics, more than one biometric. You can, like Aadhaar is using a fingerprint and the iris. You can use retina and hand. You can use face and iris. Like that, you can combine two biometrics, that is multiple biometrics. You can also have multiple units of biometrics. Right index finger and middle finger. Left thumb and right thumb. If you go for a US visa interview, they take all the 10 fingers. They take all the 10 fingers. That is it's a multiple units. 10 fingers they take for the biometric in the US embassy. It is multiple units are there, not more, not 1, but 10. Multiple snapshots of the same biometric, that is also possible. You take one biometric from one angle, you can take another snapshot from another angle. Multiple sensors you can use for biometrics. Different sensors. You can be a pressure sensor, a heat sensor, or a pressure sensor and a temperature sensor. You can have different optical sensor and a capacitance sensor. You can have different types of sensors also. And finally, multiple matches. One matching using some algorithm. See, this is if you see some in this fingerprint, you see some minutiae. These are called minutiae. This is one matchup. You look at these minutiae. You can see in the black some white dots are highlighted. Here you see a totally different, some sort of pattern is taken. So it is a multiple matchup that is available. So we can have these kind of different ways to have multimodal biometrics. Have different, which is the most common way is having multiple biometrics, having different biometrics, two different biometrics. That is the most common. Aadhaar card is also like that. You are giving your fingerprint and your iris this thing. So there are two. There is but then these are not so efficient, but still they are good options if you cannot afford to have a biometric with two different traits or two different characteristics like face and fingerprint. You can perhaps go for one trait but have multiple sensors for the trait, multiple matches, multiple snapshots, or multiple units of the same trait. These are options that are available. Now, how do you make these multimodal biometrics? you can do what is known as a fusion. A fusion can happen at different levels. So suppose you are taking the Aadhaar, you are giving your fingerprint and your iris. The fingerprint goes here, the iris goes here. The fingerprint, the extraction, feature extraction happens. The iris, the feature extraction happens. And the fusion module combines the features from both the biometrics and then stores in the database. Second time you give your biometric, same thing happens. The fingerprint goes here, the features are extracted, the iris goes here, the features are extracted, it is fused, and then you do a matching. So this is one level of fusion. Now there is another level of fusion where fingerprint is given here, the fingerprint is stored in the database after feature extraction. Iris is given to the database. Iris is also stored in the database, and second time you give separately, they are matched. So separately they are matched. So first time you give your fingerprint, the feature extraction is taken, it is stored somewhere. First time you give the iris feature extraction happens, it is stored somewhere. Second time you give the fingerprint, that fingerprint is extracted features and that is matched. Second time you give the iris, it is extracted and matched. So there are two matchings happening. And only if both the matching confidence value is 1 and 1, that is, this is matched, but this is not matched. Unless both are 1 and 1, you know about this logic, no? 1 and 1, it's like an AND gate. Only when there is an 1 and 1, you will get a fusion, and then you get the decision. So if your fingerprint matches but your iris doesn't match, it doesn't accept. Finally, the fusion can also happen at another level where things are all happening separately. Fingerprint is given, fingerprint decision is given, iris decision, and both the decisions have to be 1 and 1. Only then you get the fusion. So these are methods to combine the biometrics so as to speak. Now, multi-biometrics are very much needed because the idea is to reduce the FAR and the FRR to the lowest possible value. And multiple biometrics are somewhat efficient in the sense that you are able to get a very small FAR and a small FRR value. Now let us see what is known as the concept of standards of biometrics. Biometric standards are very much evolving. There is no one single standard. The reason is today biometrics has developed in a very big way. We are seeing immigration authorities using biometrics and fingerprints and biometric passports for travel. We are using for banks, we are using for attendance. So there is a need to have standards. Unfortunately, standards, there are many bodies that govern these standards, and many of them there are geopolitical issues, right? If you take, I don't know if your parents might be, today all of you are using CDs and DVDs. There used to be a time when people were using video cassettes. Video cassettes were like, there were two types of video cassettes. One group of companies was promoting a standard called VHS. When I was in school, I remember you have to go to a video library, rent a video, you have to take a VHS or a Betamax tape. VHS tape is big, Betamax is smaller tape. And sometimes that when you go to the video, you want to see a movie, you'll say, no, VHS tapes are all over. You have to go for a Betamax tape. There are different standards are there, different standards developed. Some companies promote these standards. Now, just to give you an example, Apple is a closed, is a completely closed company. Agreed. I think it is the most innovative company ever. And from last 10 years, I only use Apple products. But it is weird. I am very conscious of the fact that, When I want to transfer this slide to my iPad, I have to go through an iCloud. It's a very long process. If I want to do a presentation, I need a separate wire to connect to the projector, and many a time that doesn't work. Projector may be old, it doesn't accept. It's a closed standard. Apple doesn't want it to be interoperable. So same issue is there with biometric standards. Standards are dime a dozen. Standards are influenced by international bodies, by national bodies, professional societies, applications, companies. IEEE will promote a standard. ACM may or may not agree. Sometimes they agree, sometimes they don't agree. It all depends upon the vested interests. Mobile phones, Nokia will promote something, Apple will not agree. Google will do something, Apple may or may not agree. IBM will do something, Google may, as you know, Google is promoting the Android platform for mobile phones. Apple is going with iOS, and you know the issues. When you have an Android phone, it doesn't talk to a iOS phone. What to do? So that is the same situation that we see with respect to biometric standards. Standards are influenced by dime a dozen international bodies, national bodies, societies, consortia. Consortia means companies. Companies will gang up together and say, all of us will do this. We will promote this. It will help us. We will not promote the other thing. You can even call it caucus. Some people call it a caucus. A caucus of companies will gang up together and make the rules, break the rules in such a way that it is beneficial to them. Same issue is there, and this is how you see this. So many standards. In international standard for standards organization, IEC, International Electrochemical Commission, ICAO, International Civil Aviation Organization, because a lot of biometrics are used for passports, for travel. International Telecommunication Union, and there may be vested interests. ISO is very much European in nature, IEC is European, ITUT is American. You know what happens, I don't need to tell you, but you will find out that there are so many standards. Some of them are, nowadays there is generally some sort of logic that you try to make them interoperable. NIST is a US based body. BioAPI is a private consortium. All of these people are putting their hands in the pie with respect to the biometric standards. It's a problem, but we have to live with it. Everybody has to live with it. ISO, IEC, ITU, international standards, but they may have vested interests. USA-based standards are INSITS, ANSI, are USA thing. BSI is UK. API is a private informal NGO who don't want any company or any country to take over. Then International Civil Aviation Organization, OASs are standards for travel. So this is a big problem, but we cannot help it. But anyway, we have to understand that the standards, it's a very complicated setup. But there are standards for biometric data interchange, for the data structure, for the security, for the system properties, for the interfaces, and so on. So there are so many issues and so many bodies, but this is a complexity that we have to live with. That is all for today. I'll close for today. That's all I wanted to cover today. Just let me take the attendance. Just hold on. I think the aerospace, there are aerospace CCE students, I don't know. Some of them have joined. Anyway, they may join only. Some of them are going to join only after the Pongal holiday. Anyways, I am making all the video lectures and I'll give them, that's the idea it seems. So I hope, I don't know if anybody is there, but anyways, I will pass on the video lectures soon. This is attendance. Today is 6th. Is there any aerospace student here? I don't think any aerospace student has joined, so I'll just skip it and go directly to the CSE and CCE, ELC students. I think they will join only later. Just 1 minute. Let me just mark them as absent. Okay, is Divya here? CCE student Divya. Divya.